In this last section of lecture 3, we will look at scope rules, but before that, let's just take a quick look at main. So main is special. It is a function, and it is special in that there's only one and should only be one function called main in any program. So that is an absolute requirement. It's true in Java, true in C++. All right, what calls main? It's part of the operating system that calls main. And those of you who are in Computer Science 248 operating system programming, we'll actually get to see some of the details of how the operating system calls a main function in a C program. So it's a little different. It's in how C works, but it's the same idea in C++. So there's a tradition that it should have a return statement, and without a return statement you get a warning, but it's not an error. So you can have main functions without returns. Sometimes you get warnings. I guess I've been writing all my C programs and C++ programs without returns, and I've sort of been ignoring the warnings when I see them. So it's just part of tradition. What we will see in operating system programming, those of you who are in it, is that a value is returned to the caller, which is in this case the operating system, and you can do some additional logic, implement some logic based on what a program returns if you were to write things like shell scripts, and that's something that's used in Linux and in Windows and in Mac OS X. In those of you who are in operating system programming, we will we'll write shell scripts, and we will use the return value of some programs. Okay. That said, will we use it in this course? No, I don't think so. This is just here for your understanding, or bigger, larger understanding of how programs work. So typically main should return int or should be a void function. That's it. They don't return double or things like that. Alright, now let's move on to scope rules. Basically same things, same way as in, it works the same way as in Java. Local variables are declared inside the body of a function and are available only within that function. And so if you have a local variable inside, for example, average, we could have used a local variable here. Double z is a local variable, and we could take all of this and paste it in this statement and return z. That would be perfectly fine. So this local variable z is completely different from this local variable z. Okay, so you cannot access this local variable outside this function. For one thing, and we will see this later, this memory for this z variable is allocated on what's called a stack, and so that only lives for as long as this function is running. As soon as this function is done, that memory is gone. There's no way to access it. Alright, so this should work. It's perfectly fine. So this is a local variable only visible inside the function while the function is executing too. You can have variables with the same names declared in different functions. We just did that. We had a main with a z, and then we had an average with a z2. Scope is local. That is that function is its scope. Okay, so scope of the z variable is 2 z's. They are both different scopes. Local variables are preferred much more than having a whole bunch of variables all over the place. The general rule of thumb is to keep variables as local as possible. So need to know basis, that is, only have those variables be limited to wherever they are needed to do their job. Okay, so Typically, we use this term called procedural abstraction. That is, we need to know what the function does, not exactly how it does it. So we just need what goes into it, what comes out, preconditions, what's expected of the inputs, what do you expect of the outputs. You want to think of these functions as black boxes. So black box is a device you know how to use, but you don't necessarily know how it works. And even if you do know how it works, you want to treat it as a black box. So you want to implement functions like a black box. The user, that is the programmer that calls the function, should only need the declaration, does not need the definition. You should not make client programmers, that is programmers who will use your function, you should not need them to read every single line of your function. Just the declaration should be enough, and then some preconditions and postconditions. So that's where those things come in really handy. Preconditions or postconditions are really useful for the people who use the functions that you write. Okay, quickly take a look at global constants and global variables. These are constants and variables that exist outside of main, and we can do that. Typically we don't. It's actually just considered bad programming style to have a lot of these. So what does it mean? It means we can have a variable like this. Int x can be declared here. Okay, we can also declare it here, but now this will work. Why? Because x is declared globally. All functions in this program that we set up can see this variable x. It's got global scope. So mainly it just means having declarations outside main gives you global scope. So let's try this, compile it, and everything works. If you wanted to have this x be local here, you can actually redeclare this. This is a new x different from this x. Okay, this will also compile. So you just want to be careful that everything in here, this x has a scope starting from here and going to the end of this block. And so it's different from this x. Okay, so those are two different storage areas of memory. You can think of it like that. Okay, so global constants and variables are declared outside the function body, and it's global to all functions in that file. If you declare something inside the function body, it's local to that function. And global declarations are typical for constants. For example, something like this: const double tax rate is 0.05. All the functions will see that. All the functions will see the same global constants. Is it possible to use global variables? We just did that. We didn't really do much with it, but it's possible. But it's seldom used, mainly because it's dangerous. We have no control over this use. If all functions can change a variable, that's pretty dangerous, because the value will depend on what order those functions were called. So that's not a good idea in general. Blocks work pretty much the same way. For example, anything that's enclosed in open, close, curly braces, those are blocks. So in loops, we use blocks. While loops, we had a block. If statements, we had blocks. Those are all blocks. And in general, these blocks can be anywhere. Turns out. So let's take a quick example. So for example, we can create a block in the middle of main. And it's always good to indent it properly so that it's readable. But here, let me see. We get an error message. So up to here, we are okay. Now the problem is we are trying to use y, but y has only scope from here to here. You might say, well, how come x works? Because remember, we made x global. If x is global, and all of main can see it, including after this block. Okay, so once again, when we declare y inside a block, any variable inside a block, that variable is only has scope from the point at which it is declared till the end of that block. So this y is not visible here. How can you make it visible? Put it outside. declare it outside and say that this is the same y. So don't declare the int here. You can declare the int, redeclare an int y here, that's fine. Now this y is different from this y. This y over here is this one. And this y over here, which one is it? It's the one with the closest scope, the most recent scope. That's the general rule in Java. You may not have used this in Java, but that was what we actually did use, even though you may not have paid attention to or had to really deal with this. It's the same rule as in Java. Okay, so in Java you can have a block inside a block, just like we did over here. And so there are specific rules about scope, and that's what we are looking at here. So you declare data inside a compound statement, and that has the block scope. And this compound statement is called block. So what is that saying? That's just saying that if you declare a variable int y here, it has the scope inside this block, actually from the point which is declared to the end. That's the scope of y, this y. The scope of this y is the point where at which it was declared in the block till the end of its block, which goes all the way to here. Okay, so that's why we can see it at this point. Now it turns out for this program you do not want this other declaration of y. This is what you really want if you want it to work as you would expect it to work. Okay. And we did this just now. Nested scope works the same way as in Java. You can have a scope inside a scope. You can have the same name variables declared in multiple blocks. That is allowed. And remember that scope is block scope. There is no ambiguity. It's just so it turns out, I mean, as far as Java, or sorry, C++ is concerned, there is no ambiguity. But you, the programmer, may not be sure if you have, for example, something like this, int y. Okay, let's just run this and see. So let's say we want a random number put into x, another random number put into y. But what we'll see instead is not this y over here. You will see an uninitialized variable. And to check that, let's just assign this. Let's not have uninitialized variables. Let's set it equal to 0. Okay, so I'm going to compile this. Should compile, yep, no errors. And then I run it. And then notice we get an average. That doesn't make sense. It only makes sense, really, when we consider that y is 0 for this call to average. Okay. And so the average of 0 and 16 is 8. So there is no ambiguity. The ambiguity, any potential, there might be confusion on the part of the programmer if you do something like this, but there is no ambiguity. C++ is very deterministic on this. Very fixed rules, and it does exactly what we asked it to do. It's just so that the programmer may not be completely clear about what the rules are. All right. So that is it. Most of these things are the same as in Java. It's just that you may not have used some of these features that are present in both C++ and in Java.